Hi everyone, today let's take a look at a question on graphing techniques. We are given an equation of a curve C, y equal to x squared plus kx minus 1 over x plus 1. And k is a non-zero constant. Part 1 of the question wants us to find the range of values for k for which C has no stationary point. And if the question mentions anything about stationary point, turning points, chances are high that we'll be looking at the dy dx. We will try to differentiate this one first with respect to x. So dy dx, I'll be using quotient rule for this. I'll be keeping the denominator, differentiate the numerator, 2x plus k. Keeping the numerator, differentiate the denominator, I'll get a 1 here over the square of the denominator. And for stationary point or turning points, I will be setting dy dx equal to 0. And we will end up with this expression here equal to 0. For this, I will be equating to 0. The denominator, I can just multiply over. I'll just left with this. And by expanding everything and simplifying it, right, we will be able to get a quadratic equation, which is x squared plus 2x plus k plus 1 equal to 0. And if we don't want to have any solution for this, that means to say no stationary point, I will be putting the discriminant to be lesser than 0. Discriminant equal to b squared minus 4ac less than 0. And by solving this, I will be able to get k plus 1 greater than 1 implies that k should be greater than 0. That will be the range of values of k in which there is no stationary point. By right, for this question, right, the value for k when k equals to 0, right, is also a solution. Imagine if you sub in a values of k here, you'll get x squared minus 1 over x plus 1, which give me x plus 1, x minus 1 over x plus 1. And you will reduce the equation into a line. And a line, of course, they won't have any stationary point. But that is why the question mentioned in the first place is where k is a non-zero constant. So we will not be including the values of k equal to 0, although it will satisfy the values of k for which C has no stationary point. Let's look at part 2 now. Part 2 says, given that y equal to x plus 3 is an asymptote, show that k equal to 4. Perhaps the first thing we will do is to try to change this expression into a proper fraction by doing a long division. Doing long division, we will be able to get x plus k minus 1 minus k over x plus 1. And since the question mentioned that y equal to x plus 3 is the asymptote, I can just do a bit of comparison here. I can see that k minus 1 will just be equal to 3. Therefore, k equal to 4. And that is what I need to show for my part 2. Okay, moving on for the last part of the question, it says state a sequence of transformation which transform the graph of this into the graph of C. Okay, let me rewrite this equation to become x squared plus 4x minus 1 because we have already shown that k should be equal to 4. And your objective for this part of the question is to show that sequence of transformation of y equal to x over 4 minus 1 over x to get the graph of C. I think the first thing I probably do, right, is I will pause a bit and look at this equation here first. Do I need to change the form of this curve before I do my transformation? Many times, right, you probably need to change this form in order to see the similarity between this and this. In this scenario, right, I think I need to change because it involves x squared, and no amount of transformation can give me the x squared here. So probably I can do a bit of long division first. Hopefully I can see a bit of similarity between them. And when I do long division, I will be able to get like x plus 3, which is the asymptote, the oblique asymptote, minus 4 over x plus 1. Okay, and now I think it looks better because this involves an x here and an x at the denominator, which is a bit similar to this. Now from here, I can start to do a bit of my sequence of transformation. Hopefully, I will be able to get this. And the first thing I want to work on is, look at this part here. This x over 4, there's a x here, the coefficient is 1 instead of a 1/4. Perhaps the first step I can try to think of is, I will replace my y with y over 4. And replacing y with y over 4, I'll get this. And if I were to multiply the 4 over to the other side, it will just give me x minus 4 over x, which is pretty good because by a bit of comparison, it gets closer already. X, there's a 4 here, there's a 4 here. Here is replace y with y over 4. I'll write down the description later on. The next step, perhaps I will attempt to do is to replace my x with x plus 1 because I want to have an x plus 1 here. I will just do a replace x with x plus 1. And I will be able to get y equal to x plus 1 minus 4 over x plus 1. And final step I will be doing is I will replace my y with y minus 2. By replacing y with y minus 2 later on, when I shift it over to the right hand side, I'll get x plus 3. I will replace, right here, replace y with y minus 2, which will give me y minus 2 equal to x plus 1 minus 4 over x plus 1. Shifting it over to the right hand side, I will get this equation, which is what I want. Now we are done with the replacement. We can just do a bit of description. The first step when you do a replacement of y with y over 4 is scaling parallel to y-axis by a factor of 4. Second step, when you are doing replace of x with x plus 1 is a translation of 1 unit in the negative direction of x-axis. And finally, when I'm doing replacement of y with y minus 2, it's also a translation of 2 units in the positive direction of y-axis. All right, when we are doing this transformation, when we are doing this description, we are actually following this particular order.